Hi, my name is Leo and I'll be covering the introduction to music programming, or more generally, ways to generate music digitally. I will give a short overview of what it means to work on a digital audio workstation, or DAW for short, and then I will talk a bit about different ways of letting an AI or machine learning algorithm do the heavy lifting of music composition. So, let's talk a bit about DAWs. These won't be very relevant to the course, but I'd argue it won't hurt to understand a bit about how music is produced digitally, and it will certainly aid you in visual representation of concepts like MIDI files and virtual instruments, which, as we will see later, can be very useful for rudimentary attempts at generating music automatically. DAWs are very useful tools for anyone who wants to produce music of any sort. There's a long list of softwares one could use: Cubase, Fruity Loops, Logic Pro, just to name a few. I've personally dabbled in some of those. The one I'm most competent at, which isn't a lot, is Ableton. You already saw Ableton in action during this very presentation because we used it to generate our audio examples. So, what exactly is a DAW? A digital audio workstation is a software solution to visually represent music and other audio in a highly interactive way. For example, Ableton allows you to drag audio files into the dedicated workspace on what's called a track. You can create multiple tracks for your song, which will all be played back at the same time, so you could have tracks for vocals, piano, drums. The world is your oyster. Different effects and modulations can then be applied to the track and automated through what's called an envelope, like this. You could also record your audio track directly into Ableton, or, and here's the exciting part, import or create by hand a MIDI clip for a virtual instrument to map onto. A MIDI clip is essentially a set of instructions on when to play which tone for how long and with what intensity. It is basically sheet music, but for computers. Here you see me dragging around notes to where I want them to be, and I can instantly play back what I just created. Say now, I'm not happy with my choice of instrument. In that case, I can go browse my library of instruments, select another one and just drag it onto the track to switch out the virtual instrument. Or I could manually tweak specific values, apply effects to the instrument, or build one from the ground up using wavetables. There is a lot you can do with the DAW. The depth of the software is almost limitless and it evolves constantly. The existence of the software has drastically lowered the barrier of entry into music production and even spawned countless new flavors of music, especially in the department of electronic music, as you can surely imagine. Now, the use of a digital audio workstation still has some barrier of entry. You need a rudimentary understanding of music theory to really create music on a DAW, but even this can be done away with if we take it one step further into the realm of entirely computer-generated music. When we use machine learning algorithms and neural networks to compose music, it no longer requires an understanding of music at all, but just the right code. There have been numerous attempts at computer-generated music dating back to 1989, where P.M. Todd and M.C. Moser used recurrent neural networks to create music. A problem here was the limitation of their short-term coherence. This problem has been solved partly by using long short-term memory cells, LSTM neural networks, but it remains the biggest problem to maintain consistency in the whole composition and not only within a phrase. In another attempt, an LSTM neural network with 3 layers and 500 neurons was trained with MIDI files of Bach's music to create music like Bach's. To achieve this, the MIDI files were transformed into text files. To reduce the data, the 88 keys of a piano were converted to 88 ASCII characters into which the text file was transposed. The goal was to get a text output that imitates the pattern of the training data as closely as possible, and to convert this text back into MIDI files. After 150 minutes of training, there was not much improvement made. The music showed rhythmic and harmonic resemblances to Bach's music, but was nothing one would like to listen to for long. It had some problems with chord progression and bigger phrases.
We may be reaching the law of diminishing returns at this point.
A more successful creator of Bach's music is Bach. It is a deep recurrent neural network also using LSTM neurons with 3 layers and is trained with around about 400 chorals of Bach. It is capable of polyphonic composition and harmonization. It learns music theory without prior knowledge and performs very well in the Turing test, meaning that listeners are often not able to tell whether a piece is a deep Bach or an original Bach. It works slightly differently because you give it a choral of Bach and it is able to produce a harmonization or reharmonize it. In another recent case, a lawyer, musician and programmer copyrighted every melody suited by law, which are 68.7 billion melodies, which they had generated by brute forcing and saved on a hard drive. They took 1 octave of Western equal temperament scale and used whole, half, quarter and eighth notes to create every possible melody within these confines. This took them only 6 days. With this they wanted to raise attention for the copyright laws on melodies, because they found them inadequate. They wanted to show that melodies are mathematical, and as nobody can own a number, why should this be the case for melodies? Also, if music is a shared language, nobody should be able to own a piece of that language.